When we look up at the night sky, we think we know what we're seeing. Tiny pinpricks of light, quiet, motionless, eternal. They've been there for as long as anyone has lifted their gaze upwards, steady companions to our curiosity. The moon bright and reassuring, Venus glimmering in the dawn, Mars glowing red like a coal in the fire. They feel almost like family worlds we've named, mapped, and in some cases even visited. They belong to us, or at least that's what we like to think. But if you pause for a moment, if you really look, there's something rather unsettling hiding in that familiarity, because every one of those dots, those comforting lights, is only the smallest fraction of what's truly out there. Behind the picture of our neat little solar system lies a universe with a far richer imagination than ours. A universe that paints worlds in materials we can barely conceive of ice, that burns oceans of molten rock rain made of glass. And perhaps in that realization lies one of the most wonderful and humbling truths in all of science, that the planets we know are merely a handful of the opening pages in an infinite library of worlds. I've always liked that idea, a library, because a library isn't chaotic. It has order, pattern, rhythm. It invites you to wander, to choose a book at random, to be surprised by what you find inside. And in the same way, the universe invites us to wander through its shelves of light, to pick up a world here, another there, and read the story that each one tells about itself. If we begin in the first room of that great cosmic archive, we find the familiar volumes Mercury, Venus, Earth, Mars, the classics, the books we've read many times before. Mercury, the innermost world, scorched and airless, racing around the sun every 88 days. Venus cloaked in thick clouds of sulfuric acid, its surface hot enough to melt lead where the pressure would crush you like the depths of an ocean. Earth, our oasis of blue and green where chemistry learned to think. Mars cold and rust red, silent yet with scars that hint at vanished rivers and perhaps the faintest memory of life. And then further out the giants, Jupiter, Saturn, Uranus, Neptune, worlds made of gas and ice, each encircled by moons and rings like delicate annotations in the margins of a grand text. We've spent centuries learning their stories. From the first crude lenses of Galileo to the spacecraft drifting beyond Neptune, we've traced their orbits, mapped their surfaces, and weighed their masses. And so perhaps naturally we came to believe we understood what a planet really is, a ball of rock or gas circling a star, more or less like the ones here at home. But that confidence was always fragile, resting on the assumption that what we could see represented what existed. It's rather like believing that the few books on your own shelf encompass all the stories ever written. In 1995, that illusion quietly fell apart. That year, two astronomers, Michel Mayor and Didier Queloz, peered at the light of a star called 51 Pegasi, 40 light years away, and noticed something odd. Its light was wobbling ever so slightly, as if being tugged by an unseen hand. The hand they realized belonged to a planet, the first confirmed world orbiting another Sunday. It was like opening the door to a vast new wing of the library. Suddenly the shelves stretched on and on. Within a few years, dozens of new worlds were found, then hundreds. Now we know of more than 5,000 planets circling distant stars, and the number is rising by the week. And the Milky Way itself may contain hundreds of billions more, each one a separate story, each one a new combination of chemistry and gravity and chance. What's remarkable is how varied those stories are. Some of these worlds race around their stars in a matter of hours. Others drift in cold solitude unbound, drifting between suns. There are planets that are larger than Jupiter, but lighter than a cloud puffed up like cosmic balloons. Others are so dense that a teaspoon of their material would weigh more than a car. We found worlds with twin suns, worlds where it rains, molten metal, worlds that glow in infrared light because their surfaces are hot enough to cook stone. Each discovery has been like turning a page in a book we didn't know existed. And in all of this, there's a kind of quiet poetry, because these are not worlds we can visit, not yet. They exist only as patterns in starlight. We detect them by watching for the faintest dimming as a planet crosses in front of its star, or by measuring the tiny tug it exerts on that star's motion. From those delicate signals, we can tell how big it is, how heavy, what its atmosphere might contain. It's an act of almost unimaginable influence, reading entire landscapes from whispers in light. When I think about it, that's what humanity has always done. We've read the universe from the light it sends us. Every new instrument we've built, from the telescope to the spectrograph to the space probe, has been a new lens through which to see the same story written in ever finer detail. And yet, for all that precision, there's still something ineffably human about this pursuit. Because to look at a distant world and imagine what it might be like to picture its skies, its oceans, its storms, is not merely a calculation, it's an act of empathy. We project ourselves into the unknown, trying to feel what it might be like to exist elsewhere. That's the essence of exploration, the fusion of curiosity and imagination. If you've ever been far from city lights, somewhere truly dark, and looked up, you'll know the feeling. The stars don't just hang there, they shimmer with depth. You can sense the distance, the immensity, and you realize with a kind of gentle awe that the light touching your eyes has traveled for tens, sometimes hundreds of years to reach you. Each photon, a messenger carrying a fragment of another world's story. That's the library I'm talking about. Not a place of paper and shelves, but of starlight and time. Each beam of light a sentence, each spectrum a paragraph, each planet a chapter in a book without end. And what I find beautiful, almost tender, is that we've only read the prologue. When we talk about our solar system, we often describe it as orderly, predictable, almost domestic. The sun in the center, the planets arranged like family portraits in a hallway. But the reality is far messier and more creative. Every system out there, every star and its planets tells a different story about how gravity sculpted matter. Some stars have giant worlds hugging close, so close that their surfaces boil. Others have rocky planets in wide, eccentric orbits. Some have none at all. Nature, it seems, doesn't obey our sense of symmetry. It experiments, it improvises. That improvisation is what makes the universe such a fascinating artist. Given the same ingredients, hydrogen, helium, carbon, oxygen, it produces outcomes of astonishing variety. Like a composer with only 12 notes, creating symphonies that never repeat. Our own Earth is just one melody among countless others. When we say planet, we tend to imagine something Earth-like, blue oceans, white clouds, maybe a rocky surface underfoot. But that's just a trick of familiarity. Out there, planets can be made of things that on Earth would be absurd. Worlds where the atmosphere is ammonia, where the seas are methane, where the crust is iron or diamond or glass. And so, as we catalogue these new discoveries, it's becoming clear that the word planet is far broader, far more flexible than we ever thought. It's rather wonderful, isn't it? The very word that once defined the boundaries of home now defines the infinite variety of elsewhere. I sometimes think of the early astronomers, Tycho Brahe, Johannes Kepler, Galileo Galilei, and wonder what they'd feel if they could see what we found. For them, the planets were divine objects, mysterious but finite, circling within a closed cosmos. For us, they're infinite in number, bound only by the reach of light. And yet the feeling might not be so different, because whether you're looking through a brass telescope in the 17th century or through a space-borne detector today, the sensation is the same. That mix of curiosity and humility, the sense that you're peering through a window into creation itself. When we talk about discovery, we often imagine it as a conquest, planting flags, claiming territories. But the real discovery is internal. It's the shift in perspective that happens when you realize how small you are and yet how capable of understanding the immense. Standing beneath the night sky, you can feel both at once insignificance and significance coexisting. The universe doesn't care that we exist, and yet somehow it has produced beings capable of caring about it. That, to me, is the most extraordinary paradox of all. Think about the sun for a moment. It's not particularly large or bright by cosmic standards. There are stars, hundreds of times bigger, thousands of times more luminous. But our sun is stable, and stability is rare. Inside its core, hydrogen atoms fuse into helium, releasing energy that travels for hundreds of thousands of years before escaping as light. That light drives everything on Earth, the weather, the oceans, life itself. Every movement you see, a leaf trembling in the wind, a heartbeat, a city glowing at night, can be traced back to the energy of sunlight. The photons that left the sun 8 minutes ago are now the reason you can hear my voice, the reason we can build telescopes to look back at the stars. And yet beyond our sun there are countless others, each one a potential hearth around which new worlds gather. Each one a candle illuminating a new page of that cosmic library. The remarkable thing is that all of them obey the same physical laws. The equations that describe how planets orbit the sun work equally well for stars orbiting the center of the galaxy, for electrons around atoms, for galaxies themselves drifting through the cosmic web. That unity is what gives the universe its coherence, its music. Sometimes when I'm at an observatory waiting for the night to fall, I like to imagine that if you could somehow translate the movements of all those planets and stars into sound, you'd hear a kind of symphony, a quiet, slow rhythm of orbit, and tides and resonances, each world contributing its own subtle note. The music of physics played across time and space. And we here on Earth are among the first creatures able to listen. Of course, we listen through instruments rather than ears. Our telescopes catch light across the spectrum: infrared, ultraviolet, radio, X-ray, each revealing a different layer of the story. It's astonishing to think that by splitting light into its component wavelengths, we can identify the fingerprints of elements in the atmospheres of planets dozens, even hundreds of light years away. Sodium, potassium, hydrogen, water vapor, each leaves a signature, a tiny dip in the spectrum. Those little dips are like punctuation marks in the sentences of starlight. Through them we can read temperature, composition, pressure, we can infer winds and clouds, and in some cases even the possibility of rain. From photons alone we can imagine landscapes. That's why astronomy is at its heart a literary science. We are readers of light, interpreters of stories written by atoms and gravity. And I suppose that's why the metaphor of the library feels so. Apartment. Each planet is a book written by its own conditions. The ink is light, the pages are time, the binding is gravity. Some books are slim, others vast, some violent, others serene. We may never visit most of them, but we can still read their titles, glimpse their themes, and imagine the rest. As we continue our tour through this cosmic library, the first room, our solar system, is the place to pause and reflect, because it's here that our understanding begins. Everything we learn about other worlds is filtered through what we know of these. Earth teaches us about habitability. Mars teaches us about loss. Jupiter and Saturn teach us about formation. Uranus and Neptune about extremes. Each one a reference volume we return to as we decipher the newer texts beyond. And perhaps that's what makes this moment in history so thrilling, that we stand on the threshold between the known and the unimaginable. We can still see the family of planets that raised our curiosity, yet we can already sense the vast alien shelves that stretch beyond. Maybe that's what it means to be alive right now, to exist at the moment when the universe has become not just visible but readable. When I was a child, I used to think the night sky was a fixed painting, something ancient and unchanging. Now I know it's a living, evolving manuscript with new words written every second as stars are born and die. We are part of that manuscript too, tiny, transient scribbles on one of its pages. But we are also the readers, the ones turning the pages, marveling at the story as it unfolds. So tonight, if you step outside and look up, remember that those pinpricks of light are not merely distant suns. They are invitations, each one saying, "There's more, keep reading." And the first line of that endless story, the line we've just read, begins here in the familiar lights of home. Not an ending, but a doorway. Not a conclusion, but the quiet intake of breath before the next chapter begins. When you walk into the great library of worlds, the air seems to change. There's a silence that isn't empty. It hums softly, as though the walls themselves are whispering the stories of the stars. And as your eyes adjust, the first thing you notice is the light. Not the white light of our sun, but something deeper, warmer, like the glow that lingers on the edge of a forge. In this first room, the shelves shimmer, and right in the center, placed as if it were the crown jewel of the collection, there's a world that gleams like no other. A world that seems, at least to us, like a miracle of excess. We call it 55 Cancri E. It orbits a star about 40 light years away in the constellation of Cancer, a modest yellow-white sun, not unlike our own, though older and quieter. The planet is close, so close that its year lasts just 18 hours. One sunrise, one sunset, every 3/4 of an Earth day. You could say it rushes through life, circling its parent star like a spark dancing on the rim of a flame. At first, when astronomers discovered it, they thought it might be another super-Earth, a rocky planet, a little bigger, a little heavier, nothing too unusual. But then the numbers started to whisper something else. You see, we can weigh a planet by the way it tugs on its star, a subtle gravitational handshake we can detect through changes in the star's light. And we can measure its size by how much starlight it blocks as it passes in front. From those two clues, mass and radius, we can work out its density. And that in turn tells us something about what it's made of. But 55 Cancri E didn't fit the pattern. Its density was far too high to be explained by ordinary rock and metal. It was heavier, more compact, more intense. The sort of density you'd expect if much of the planet were made, not of silicates like Earth, but of carbon. And if a world is made mostly of carbon, then under the crushing pressures deep inside, pressures millions of times greater than those at the bottom of our oceans, carbon atoms begin to knit together in a way that's both familiar and almost unbelievable. They become diamond, not scattered gems beneath the soil, not rare treasures buried in volcanic pipes, but diamond as geology, diamond as bedrock, as landscape, as world. Imagine that for a moment. A planet twice the size of Earth, made not of granite or basalt, but of pure crystalline carbon. mountains of diamond rising from glowing plains of graphite, deep beneath a mantle of solid diamond, stretching for thousands of kilometers. It's difficult to picture because our minds reach instinctively for beauty, for sparkle and clarity, but 55 Cancri E wouldn't look like the stones in a jeweler's case. It would be dark and hot, the color of coal under fire. Its day side faces the star permanently locked by tidal forces, so that one hemisphere endures endless daylight, while the other is bathed in perpetual night. On the bright side, the temperature may reach over 2000 degrees Celsius. Rock would glow cherry red, metals would melt. Perhaps rivers of molten carbon would slide between jagged diamond ridges, glinting briefly in the infernal light before cooling to glass. On the far side, shielded from the star, the heat might fall just enough for a crust to form a landscape of black crystal under a sky of frozen twilight. Between them, a terminator line, a twilight band that circles the planet, forever balanced between light and darkness. Perhaps if any form of atmosphere still clings there, it would shimmer like smoke illuminated by the fire from one side and the starlight reflected from the other. We can't see those details, of course. We can only infer them from numbers and light. But numbers in astronomy are not dry abstractions, they're clues, each one a hint of what's possible. And what's possible here is staggering. A diamond planet. When scientists first proposed it, headlines called it a world worth quadrillions, as if you could measure it in carats, as if its beauty could be priced. But the truth is, value doesn't exist out there. It's a human invention. To the cosmos, a diamond is just another arrangement of atoms, a natural product of carbon under pressure. On Earth, we call it rare, we call it precious, we cut it and set it in rings to celebrate love and permanence. But on 55 Cancri, it's just geology. Their diamond is as common as stone. What's priceless here is ordinary there. And that perhaps is the lesson, that beauty and worth are not absolutes. They depend on perspective. I think about that sometimes, how the universe rearranges our hierarchies, how it takes the things we treasure most and makes them mundane, and takes the mundane and turns it sublime. If we could somehow visit 55 Cancri E, if we could survive the radiation, the heat, the gravity, we wouldn't find a paradise. We'd find a furnace. A place where the very air might glow with vaporized rock, where the sky could rain droplets of molten carbon, where the horizon itself might shimmer like the inside of a crucible, and yet in its violence there's elegance. Because everything there, every storm, every spark, is driven by the same forces that shaped us. Gravity, temperature, pressure. The same equations that describe how carbon turns to diamond inside the Earth apply there, just magnified beyond our imagining. That's the great unifying idea in physics: the laws don't change. The universe is consistent. From the heart of a star to the core of a planet, from your breath to the orbit of galaxies, the same principles hold. And so when we talk about 55 Cancri E, we're not describing something alien in the sense of being unreachable. We're describing another verse of the same cosmic poem, the same grammar of matter rearranged in a different stanza. It makes me think that the universe is less like a machine and more like an artist. It takes a handful of elements, hydrogen, helium, carbon, oxygen, and keeps finding new ways to combine them. Here a world of water and air, there a world of fire and stone. And sometimes, just for the sake of variety, a world of diamond. It's almost playful. Now we should be careful. Not every scientist agrees that 55 Cancri E is truly made of diamond. Some recent measurements suggest it might instead be covered in lava oceans, or that it's enveloped in a dense atmosphere of carbon dioxide and silicate vapor. But whichever model turns out to be right, one thing is clear: it's extreme. It reminds us that planets are not static marbles circling in the dark. They're dynamic worlds shaped by the chaos of formation, by collisions, by heat, by chance, and in that chaos, nature finds endless creativity. For most of human history, we imagined the heavens as perfect, smooth, unchanging spheres. But what we found is the opposite. The universe is rough, passionate, wild, and somehow that's far more beautiful. The discovery of 55 Cancri E and of other carbon-rich worlds like it opened a new chapter in planetary science. It forced us to realize that the recipe for a planet is not fixed. The ingredients depend on the chemistry of the star it forms around. Our sun, for instance, is rich in oxygen, so our planets are built mainly from silicates, combinations of oxygen and silicon, the familiar stuff of rock. But if a star's birth cloud contains more carbon than oxygen, the chemistry flips. Oxygen binds to carbon to form carbon monoxide, leaving the remaining carbon to pair with silicon and metals, forming carbides instead of oxides. Out of that comes a whole new kind of geology. Mountains of silicon carbide, plains of graphite, mantles of diamond. A carbon planet. So you see 55. Cancri E isn't an anomaly, it's an expression of cosmic diversity, a product of chemistry played in a different key, and that's why I find it so beautiful. Not because of its material, though diamond has its own allure, but because of what it represents possibility. It shows us that the universe doesn't repeat itself. Every system is a new experiment. Every star, a fresh attempt at creation. If you could stand in orbit around that star, if you could float above that glittering world, the sight would be astonishing. Below you a hemisphere glowing orange-red, alive with motion. Rivers of molten carbon twisting and colliding, releasing vaporous plumes that curl like smoke into the void. Above a star that dominates the sky 10 times larger and brighter than our sun appears to us. The light would be relentless, shadows would be sharp and fleeting. And then as you drift toward the dark hemisphere, the glow would fade into a deep crystalline black. The heat would fool the air, if there is any, would thin. You might see diamond ridges catching the faint reflected light from the star, a landscape carved from pressure and time. It would feel less like a planet and more like an artifact, something forged deliberately, the sculpture of an ancient cosmic artisan. But of course it isn't deliberate, it's inevitable. Given the right ingredients and the right conditions, nature has no choice but to create such things. That's what makes science so moving, the recognition that the universe doesn't need intention to produce beauty. It simply follows its laws, and beauty emerges as a consequence. Perhaps that's why I've always found astronomy so profoundly human, because when we look at a world like 55 Cancri A, we don't just see a planet, we see reflection. We see ourselves in it the way artists see themselves in their work. We see the same curiosity, the same restlessness, the same drive to transform the ordinary into the extraordinary. In that sense, 55 Cancri E is not merely an object of study. It's a mirror showing us what our own imagination looks like when extended across light years. And think all of this wonder has come from light. From photons that left that star 40 years ago, travelled across the vacuum, entered a telescope on Earth and bent through a prism. From that light we read temperature density chemistry. From that light we built a picture of an entire world. That's the power of science. It allows us to see what we can never touch, to hold in our minds the image of something utterly alien yet entirely real. There's a quiet humility in that too, because as much as we've learned, we know there's far more we don't. 55 Cancri E might be a diamond planet, or a lava world, or something stranger still. But whatever it is, it's a reminder that the cosmos doesn't conform to our expectations, it exceeds them. And so we turn the page. We linger for a moment among the glittering shelves of this first room, listening to the hum of physics and fire, and then we move on deeper into the library where stranger tales await. The next room is darker, colder and yet hotter too. It's a place where opposites coexist, where day and night are divided forever, where oceans of fire meet plains of ice. It's time to step into the world of paradox, the world of fire and frost. When you leave, the glittering chamber of diamonds behind the air seems to cool, though that of course is only a feeling. In truth, there's no air here at all, only silence and starlight. We step through a new doorway in this great cosmic library, and suddenly the light changes again. The glow of molten carbon fades into something more divided, more conflicted, like a painting split in two, half cast in the warmth of sunrise, half in the blue hush of eternal night. And here on the pedestal, at the center of this second room, lies a world that lives forever on that border, a world of fire and of ice. It has no name you'd remember. Its catalogue designation is long and forgettable, one of thousands of numbers and letters that mark the planets we've found beyond our Sunday. But it represents something fundamental, a kind of cosmic compromise. It's what happens when a planet drifts too close to its star and becomes locked, tidally trapped, so that one hemisphere always faces the light, while the other forever turns away. The same gravitational embrace that keeps the moon showing only one face to Earth can, in these close orbits, freeze an entire planet in a strange eternal rotation. One half burns, the other freezes. And between them, in a narrow twilight ring around the planet, there might exist a region where neither extreme prevails. A narrow strip of perpetual dusk, a band of temperate possibility. We can imagine standing there just on the edge of night. To one side, the horizon would blaze with a star fixed forever, in the same place in the sky, never setting, never moving, a disk of unbearable light flooding the landscape with heat. To the other, darkness would stretch endlessly, the stars sharp and cold and close. The ground beneath you would be scarred and uneven, torn between expansion and contraction, between molten flow and frozen crust. And yet right where you stand, it might feel almost calm. almost Earth-like. Almost. This strange dance, this gravitational tethering is familiar to us. We see it every night in the face of the moon. The moon's day is its month. It spins once for every orbit around the Earth. One hemisphere forever gazes our way, while the other remains hidden, not dark but unseen. That same mechanism writ large and fierce sculpts the fates of countless exoplanets that circle their stars at blistering distances. They're caught in a tidal grip so strong that friction within their crusts heats them, reshapes them, stretches and kneads them like dough. The forces that hold them steady also tear them apart. On the day side of such a world, temperatures can soar to several thousand degrees, enough to melt rock into oceans of lava, to vaporize metals into clouds. On the night side, the air, if there is any, would condense and fall as snow-building glaciers of frozen gases. The atmosphere itself might shudder, streaming violently from hot to cold, driven by supersonic winds. It's chaos sculpted into permanence. A world forever out of balance, yet somehow sustained by that very tension. Astronomers have observed many planets like this. Some are giant hot Jupiters the size of our own Jupiter, but orbiting closer to their stars than Mercury does to the Sunday. Others are rocky, smaller, more Earth-like in mass, but far stranger in temperament. Each one offers a glimpse of how diverse planetary climates can be. There's one system in particular, Kepler 10b, that comes to mind. A rocky world with a year less than a single Earth day, scorched to nearly 3,000 degrees on the side facing its star. Its surface might be a roiling sea of molten rock, and yet swing around to the dark hemisphere and the heat vanishes. There the temperature may plunge hundreds of degrees below freezing. Imagine that contrast: oceans of fire under a static sun, mountains of ice under a black sky, a planet torn in half by light. It sounds impossible, doesn't it? But nature rarely chooses simplicity. The balance between heat and cold, between energy and stillness, gives rise to forms we could scarcely predict. In fact, it might even allow for something profound. Because somewhere between those extremes, at the edge of the lava seas, where heat and cold wrestle to a draw, conditions might just become moderate. Not comfortable, not gentle, but perhaps survivable. Temperatures that, while extreme, could allow certain molecules to remain stable, liquids to exist for moments, maybe even longer. That narrow ring of twilight, that band between day and night, has a name: the Terminator Zone. It's a region of perpetual dusk where the star never rises nor sets. The sky there would be surreal, a soft amber glow on one horizon, a black void on the other. The light would come not from overhead but from the edge of the world, filling the air with long shadows. If life were ever to exist on a tidally locked planet, it might find refuge there in the twilight. Imagine creatures evolved to follow that border, migrating slowly around the planet as the crust shifts and cools, always staying within the thin line between too hot and too cold. A civilization perhaps that has never seen sunrise or sunset, because for them the sun has never moved. It's a haunting thought, a world without time as we know it. No days to count, no nights to rest. Just an eternal present fixed between the fires of day and the frost of night. There's something strangely human about that image, isn't there? The struggle to exist between extremes, to find equilibrium in the tension. We do it all the time, between reason and emotion, between ambition and peace, between certainty and wonder. Perhaps it's not just life that seeks balance. Perhaps the universe itself does. When I first read the data from these tidally locked worlds, I remember thinking, this is how the universe tells us it doesn't play favourites. It creates beauty out of chaos, symmetry out of tension. It allows light and dark to coexist, not as opposites but as partners. Even here, where the surface temperature swings by thousands of degrees, there is still order. Energy flows from hot to cold winds, circulate matter, condenses and rises again. It's a grand, restless equilibrium, the same principle that keeps stars burning, galaxies spinning, and life on Earth thriving. And that's the great paradox: even in extremes there is harmony. If you were to hover above such a world, you'd see the dividing line curving below the bright half, glowing like a brand, the dark half swallowing light like ink. The atmosphere, if there is one, would ripple and stream between them, glowing faintly with heat as it carries energy from day to night. It would look alive, a planetary heartbeat. In some models, the winds on these planets can reach several kilometers per second, faster than any jet, faster than sound itself. The gales howl across continents of molten rock, carrying vaporized minerals into the dark, where they cool, condense, and fall as rain. And then as the circulation continues, they evaporate again. The world breathes in this rhythm endlessly. I suppose that's one of the most astonishing things about planetary science. It reveals that even in places that seem utterly hostile, there's a kind of logic, a beauty in the mechanics of their suffering. These are not failed worlds, they're successful expressions of their circumstances. It's easy to think of Earth as the measure of all things, but it isn't. Earth is merely one solution among many. The universe has found countless others, some more violent, some more fragile, some far stranger. And perhaps hidden somewhere among them are worlds not entirely uninhabitable, not comfortable by our standards, but marginal, existing at the edge of survivability. If the chemistry is right, if the winds circulate just so, if the right molecules persist, maybe, just maybe, there are places where life has adapted to the twilight. Life, after all, is resourceful. It thrives in boiling vents at the bottom of our oceans, in the ice of Antarctica, in clouds of acid in rock miles beneath the surface. If it can exist here, why not there? If there are beings somewhere on a world like this, they would live perpetually at the border of light. Their myths would speak not of dawns and sunsets, but of the eternal glow that divides existence. To us, such a life sounds bleak. To them, it would be normal, their version of balance, their definition of peace. I sometimes wonder if that's the lesson of these tidally locked planets, that stability doesn't mean sameness. It means tension held perfectly still, and that's something we can learn from. Because in a way, we too are tidally locked, not to a star, but to our own small world. We face the sun, we rotate, we orbit bound by gravity, pulled by time. We live between opposites, chaos and order, life and death, knowledge and mystery. And like those worlds, we find our meaning in the narrow band between them. Back in the cosmic library, this second room feels colder, quieter. The shimmering heat of the diamond world has faded, replaced by the pale gleam of ice and the dull red of embers. The story written here is not one of wealth or splendor, but of endurance. Because in this world, survival is a delicate compromise. It's a story of a planet that refuses to choose between day and night, that holds both forever. As you turn away, the light behind you shifts, as if the star itself were winking through the haze. And you realize that you're only halfway through the collection. Somewhere ahead in another room, the light will change again, this time to blue. A deceptive blue, bright and inviting, like the color of Earth seen from space. But it's not Earth. It's a world where the winds scream at thousands of kilometers an hour, and the rain falls not as water, but as molten glass. We've seen diamond, and we've seen balance. Now it's time to see beauty made dangerous. Let's step into the next room. If you keep walking through the cosmic library, past the glowing chamber of diamonds and the cold divided hall of fire and ice, you eventually reach a door that hums. You can almost feel the vibration in the soles of your feet, a low thrumming tone that seems to echo through the airless void. And as it opens, light pours out, blue light. Not the soft, familiar blue of an earthly sky, but something more vivid, more electric. It's the kind of blue that seems alive, pulsing as though the very air were made of flame. This is the third room. And here the story on the pedestal is not of wealth nor balance, but of beauty, the kind that is both breathtaking and lethal. The planet is called HD 189733b. It lies 63 light-years away in the constellation of Vulpecula, the Little Fox. Through the eye of the Hubble Space Telescope, its color leaps out a deep cerulean blue, like the oceans of our own world seen from orbit. When astronomers first saw it, there was a flicker of wonder, that momentary irrational hope that perhaps, just perhaps, this was a place like home. After all, we are drawn to blue. To us, it's the color of calm, of open sky, of water of life. But as we looked closer, the illusion began to fall away. Because the blue of HD 189733b doesn't come from oceans, it comes from storms. The color is born of silicate, tiny particles of glass suspended in its atmosphere. When starlight strikes those particles, they scatter blue light more strongly than red, much like our own sky does with air molecules. But here, the scattering isn't gentle, it's violent. The winds that carry those silicate grains rage at over 2,000 kilometers per hour, faster than the speed of sound. So if you were standing there, which of course you couldn't, the sky above wouldn't be a tranquil dome of color. It would be chaos. Shards of glass whirling sideways through the air, slicing across the horizon, carried on hurricane-force winds that never stop. It rains glass, sideways. It's almost impossible to imagine. But try. Picture a world where the clouds are made of vaporized rock silicates rising from the heat below, condensing high in the atmosphere, then falling back as droplets of molten glass. Every droplet torn apart mid-fall by supersonic gales, glittering briefly like sparks before shattering into dust. It's beautiful and horrifying. A sapphire marble gleaming serenely from afar, yet closer in a storm that would flay any solid thing to powder. In a way, it's a perfect metaphor for the universe itself, how it often hides violence beneath beauty. We see the light, not the fury. The same sunlight that gives warmth can also burn. The same gravity that builds planets can destroy them. And yet out of that balance between creation and destruction, new forms of beauty are born. HD 189733b belongs to a class of worlds we call hot Jupiters, gas giants like our own Jupiter, but orbiting perilously close to their stars. This one circles its parent every 2.2 Earth days at a distance, only 3 million miles away, about 1/13 the gap between Mercury and the Sunday. At that range, the star fills its sky, a burning disk, so bright it would outshine any notion of night. The planet is tidally locked, so one hemisphere is scorched, reaching temperatures of over 1,000 degrees Celsius, while the other remains slightly cooler, swept by winds that try and fail to carry the heat around. In those winds, the elements that would form rock and sand on Earth are turned to vapor, rising and swirling until they condense into droplets of silicate rain. And that's where the blue comes from, not water but glass. The more you think about it, the more you realize how deceptive color can be. From afar, this world looks calm, even peaceful. It shines like a jewel. But its beauty is the beauty of a flame, or a lightning strike, or a predator's eye, mesmerizing yet lethal. If you were to hover in orbit above it, you'd see bands of storm wrapping the globe, shifting and curling like brushstrokes of cobalt light. The Terminator line between day and night would shimmer faintly, a boundary of energy where hot gases surge and cool ones descend. You'd see the upper atmosphere glowing as it catches the star's radiation, a translucent halo of sapphire mist. And beneath all that splendor, a chaos of motion. Every atom fighting to move, to balance, to survive the constant onslaught of light and heat. It's easy to forget that this is not fiction. We know these details not because we've been there, but because we've learned to read light with extraordinary precision. When a planet like HD 189733b passes in front of its star, some of the starlight filters through its atmosphere. Different gases absorb different wavelengths, leaving behind a fingerprint, a pattern of missing colors that tells us what's there. In 2007, astronomers used this method to detect sodium in its atmosphere. Later they found hydrogen and oxygen, but in ratios unlike anything we know. The signatures hinted at silicates, confirming what theory had predicted, a world of glass storms. And so through the narrowest of clues we saw the true nature of that blue. We realized that the universe doesn't simply repeat itself, it reimagines. The same ingredients that make sand and sea here make hurricanes of glass elsewhere. And that's why I think HD 189733b is one of the most hauntingly beautiful discoveries we've made, because it challenges the way we think about appearances. It asks us to look deeper than color, deeper than light. From Earth we crave familiarity. We look for reflections of ourselves, oceans, skies, clouds. But when we search the galaxy, we find that nature's imagination is far more daring. It takes what we know and turns it inside out. To me, there's something profoundly philosophical about that. Because in our daily lives, we often confuse beauty with safety, familiarity with truth. But the universe shows us that the most captivating things are sometimes the most dangerous, and that danger itself can be magnificent. There's a quiet humility in that realization, because it reminds us that our aesthetic, our sense of what's serene or violent, what's gentle or harsh, is local. It's Earth's language written in water and air. The cosmos speaks in other tongues. In the airless hall of this library, the story of HD 189733b sits open on a pedestal of light. The pages shimmer with blue and white, but if you look closely, you can see the wind rippling through them. You can hear the faint hiss of glass against glass. The story it tells isn't about destruction or cruelty, it's about process, about how even the most violent forces can create something astonishing. If you think about it, that's true everywhere. Stars are born from the collapse of clouds, destruction leading to creation. Planets form from collisions, debris, and fire. Life itself began in the turbulence of early Earth, in heat, in pressure, in chaos. The same storms that strip away old forms make room for new ones. So perhaps when we see this world of sideways glass rain, we shouldn't think of it as hellish. We should think of it as an unfinished sentence, a stage in a story still being written. In time, its heat may fade, its orbit may widen, its atmosphere may cool. Perhaps one day it will become something else entirely. A place where glass no longer falls, where light and dark find peace. Because that's what the universe does, it transforms. Slowly, quietly, relentlessly, it never stands still. And as I stand in this room, this blue chamber of storms, I can't help but feel that we too are part of that same transformation. We are not observers separate from the story, we are characters within it. Made of the same atoms, shaped by the same forces, bound by the same physics, we are in every literal sense the universe reflecting on itself. And that, I think, is what makes all this so moving. When you close the book on HD 189733b, the light in the room softens, the wind seems to fade, and somewhere deeper in the library another door begins to glow. It's quieter, warmer filled, not with spectacle, but with understanding. Because to truly read these worlds, to make sense of their light and colour and chemistry, we need to understand how we read them at all. The next room isn't about the planets themselves, but about us, the readers, the interpreters, the ones who turn light into meaning. Let's walk there now, into the next chamber. The one watched over by a librarian of sorts, the keeper of light. The one who reminds us that though we cannot touch these worlds, we can still know them. Because the stories they write are not on paper or stone, they're written in the language of light itself. When the blue light fades and the echo of those glass storms falls quiet behind you, the corridor of the cosmic library opens into a new kind of space. It's darker here, softer, more deliberate. The walls don't shimmer now, they hum faintly as if lined with strings of light. And in the centre of the room stands a single figure, not a person of course, but an idea, the librarian. Not the kind who dusts books or stamps dates, but a keeper of the oldest archive in existence, the archive of light. And the shelves around her are not filled with paper and ink, but with spectra, each one a signature, a melody written in the language of physics. This is where the stories of those impossible worlds are stored, the diamond planet, the world of fire and ice, the blue storm that rains glass. And what's remarkable is that we've never been to any of them. We've never sent a probe, never taken a sample, never seen them with human eyes, and yet somehow we know them. It's strange, isn't it, that from a point of light so faint it barely registers in the dark, we can reconstruct entire worlds. We can tell how big they are, how heavy what they're made of, how fast they orbit, even what their skies contain. All from photons, particles of light travelling across tens, hundreds, even thousands of light years, arriving quietly at our telescopes. If there is a magic in science, this is surely it. The librarian of the cosmos doesn't whisper words, she whispers wavelengths. And every colour, every slight dip or rise in brightness tells us something. The first method she taught us is simple, though it feels like sleight of hand. We call it the transit method. When a planet passes in front of its star, even from unimaginably far away, it blocks a tiny fraction of the starlight, a dimming so small that for many stars it's less than 1 part in 10,000, yet we can see it. Our instruments like the Kepler Space Telescope and its successor TESS watch for that faint rhythmic flicker, a dip that repeats every orbit every few days or weeks. From that alone we can measure the planet's size. The bigger the dip, the larger the world. It's like watching a moth pass in front of a distant candle and inferring the width of its wings from the briefest shadow. But light can tell us more. The librarian opens another page, this one filled with colour stretched out into a rainbow. When the planet transits, some of the starlight filters through its atmosphere. Different gases absorb light at different wavelengths, leaving dark lines in the spectrum. By studying those lines, we can tell what the atmosphere is made of: hydrogen, sodium, water vapour, methane. It's called transmission spectroscopy, and it's one of the most powerful tools we have. Think about that for a moment. We can tell the weather on a world 60 light years away without ever leaving home. It's not unlike reading a book through the reflection in a window. You don't see the words directly, you see the distortions, the glimmers of meaning carried in the light. And from those distortions you piece together a story. That's what astronomers do. They are readers of distortions. They sit at the edge of an ocean of light and listen for ripples. Sometimes the librarian lets us see even more. When the planet moves behind its star, what we call secondary eclipse, the star's light briefly dominates. By subtracting that from the combined light, we see when the planet is visible, we can isolate the planet's own glow. From that we can measure its temperature, even its colour. And when we track how that glow changes as the planet orbits, we can map its day and night sides, infer the shape of its clouds, the flow of its winds, all from light. It's almost incomprehensible. We are reading the universe through the faintest of signals, through information carried on beams that have crossed unimaginable distances. Each photon a messenger from the other side of the galaxy, carrying a story about where it came from, and yet we've learned to translate those stories. In 2019, the Hubble Space Telescope detected water vapour in the atmosphere of a planet called K218b, about 110 light years away. It's larger than Earth, smaller than Neptune, orbiting in its star's habitable zone. The discovery didn't mean there was life, of course, but it meant something almost as profound. It meant that worlds like ours might not be rare. that water, that most delicate and essential ingredient, might be common. It's extraordinary, isn't it, to look at a point of light and know that somewhere around it water moves through air. And now with telescopes like the James Webb Space Telescope, the librarian's archive has grown deeper still. Webb can see the infrared signatures of carbon dioxide, methane, even complex molecules, the building blocks of life. It's capable of reading atmospheres on planets tens of trillions of kilometers away, distinguishing between gases, tracing the faint fingerprints of chemistry across the void. It's as though after centuries of reading by candlelight, we've finally been handed a lamp. And all of it from the diamond crust of 55 Cancri E to the sapphire storms of HD 189733b, has been revealed not by travel but by interpretation. We are not explorers in the old sense, not sailors crossing oceans or climbers scaling peaks. We are explorers of information. We navigate data, decode spectra, translate the language of light. The librarian doesn't show us pictures. She teaches us to imagine. She invites us to rebuild these worlds in our minds, to turn graphs into landscapes, numbers into skies. And I think that's something quietly profound, because it shows that exploration has never really been about distance. It's about understanding. When we decipher a spectrum, we're not just learning about a planet, we're discovering that the same laws of nature apply everywhere. The same hydrogen that fuels our sun fuels the stars 1,000 light years away. The same oxygen that fills our lungs leaves its mark in alien skies. The same carbon that forms our bodies builds the cores of planets, the dust of comets, the hearts of diamonds. There's unity in that, a oneness that runs through everything. If you look closely at the shelves of this library, you'll see that every spectrum, every curve of light is built from the same elements, the same fingerprints. They differ in proportion, in context, in temperature, but not in essence. It's like discovering that every book in the universe is written in the same alphabet, and that alphabet is physics. Perhaps that's what the librarian represents. Not knowledge as possession, but knowledge as connection. A reminder that the further we look out, the more deeply we see ourselves reflected back. Because when you think about it, what are we doing when we study other worlds? We're trying to answer one simple question: are we unique? And every new planet we find, every spectrum we decode, brings us closer to the answer, not in the form of certainty, but of context. If the universe is filled with other worlds, other combinations of chemistry and light and weather, then perhaps the emergence of life is not an accident. Perhaps it's part of the universe's grammar. That's what the librarian shows us, that meaning doesn't come from isolation, it comes from comparison. We learn what Earth is by seeing what it is not. We understand life by studying where it might not be. And so the more worlds we find, the more precious our own becomes. When you think about it that way, science and art are not so different. Both are acts of empathy, attempts to understand something beyond ourselves. Both begin with wonder, and both end with connection. I often imagine that if the universe could speak this room, the librarian's chamber would be its voice. Not loud, not commanding, but calm, steady, full of patience. A voice that says, look carefully, everything you need to know is already written in the light. And maybe that's why I find this part of the library the most moving. Because it isn't about spectacle, not about molten diamonds or sideways glass rain, but about comprehension itself. About the fact that we, tiny and brief as we are, can read. We can read the universe. That's what the librarian reminds us of, that knowledge is not just power, it's participation. It's the way the cosmos becomes conscious of itself. When you stand here long enough, you begin to hear it, a soft murmur, the sound of data flowing of photons, arriving of spectra forming. It's the sound of understanding being born. And you realize something simple and beautiful, that every telescope, every detector, every equation, they are our way of listening. Listening to the stories of distant worlds written in the only language the universe speaks, fluently light. And somewhere beyond these walls of knowledge, more light is on its way. Photons, leaving new stars, new planets, traveling for years, centuries, millennia, each one carrying a new story, waiting to be read. Perhaps that's the greatest comfort of all, that the library is still growing. So when you walk back toward the doorway and the glow of the next room begins to spill in, warmer, more golden, you understand what comes next. The librarian smiles, though she has no face, and you feel the gentle nudge of curiosity once more, because the library of worlds isn't finished. There are still shelves, unwritten lights yet to arrive. And in the next chamber, we'll find out what all of this means, not just for astronomy, but for us. The final room of the cosmic library isn't about data or discovery, it's about imagination, about the infinite creativity of the universe itself. and the quiet, humbling realization that we are part of its story. When you leave the librarian's chamber, the light changes once again. It's softer now, golden diffuse, as though filtered through the dust of a billion suns. The air feels still, almost reverent. You have walked through rooms of fire and diamond, of wind and glass, of light and meaning. But here at the heart of the cosmic library, there are no more exhibits, no more pedestals, only space, vast open waiting. This is the final room, the room of imagination. And though it is the quietest, it might also be the most powerful, because here the shelves never end. They stretch beyond sight, beyond thought, each one holding a story still unwritten, a world still unborn. The air, if there were, air would be heavy with potential. You can almost hear the ticking of distant stars, the whisper of atoms assembling themselves into patterns of possibility. This is where the universe keeps its future. You see, for all we've learned, all we've measured, all the light we've read, we've only opened the first few chapters. The cosmic library is still being written. Every photon that reaches us is a new word, every discovery a new sentence. Every unanswered question, and there are so many, is an unfinished page. The universe, in a very real sense, is dreaming itself into being. We once thought our own solar system was the template for creation, that planets must orbit neatly, that life required a very particular recipe, that the cosmos was stable, predictable, complete. But the last few decades have shown us how narrow that vision was. The reality is far more imaginative. There are worlds with two suns, their skies painted in eternal dawns. Worlds that drift alone unbound, cast out from their stars, wandering like cosmic exiles through the dark. There are planets of methane, of iron, of ice, of diamond, of glass. Some glow with the heat of their birth. Others are colder than the void around them. Some are vast enough to swallow Jupiter. Others are smaller than our moon. And all of them are real. All of them are natural. All of them are the result of the same laws that shape us. When you step back and see it whole, it feels less like a machine and more like an artwork, a living, breathing sculpture carved by gravity and time. Each world a brushstroke, each star a colour, each galaxy a canvas. And if the universe is an artist, then its medium is change. Because nothing here stands still. Stars are born, burn and die. Planets form, collide and reform. Elements fuse and decay. Even the galaxies drift apart, pulled by the silent expansion of space itself. The universe is not a gallery of fixed exhibits, it's a performance unfolding over billions of years, a symphony still being composed. And somehow, against all odds, we are part of it. A species that has only just learned to read, sitting on a small blue planet around a modest star, trying to make sense of it all. Sometimes when I think about that, I find it almost impossible to believe. That consciousness, this fragile, flickering awareness, has emerged from the dust of stars and now stands here reflecting on the whole. That the same atoms that once drifted in nebulae now form the neurons that wonder where they came from. It's as if the universe, having created structure, gravity, chemistry, life, has taken one final step to create curiosity, to give itself the ability to look back and see. We are the cosmos made conscious. We are its memory, its awareness, its voice. And maybe that's the real reason the library exists, not so that it can be admired, but so that it can be understood. So that somewhere, somehow, the universe can know what it has made. When I look at the night sky, those same dots of light that ancient eyes once saw, I no longer see a ceiling. I see shelves, each one holding a story, a possibility. Some of those stories have already been written, the tale of Earth, of life, of our sun's slow unfolding. But most are still blank, waiting for readers, waiting for us. And here's the remarkable thing, we are still writing too. Every time we build a new telescope, launch a new probe, ask a new question, we add another chapter. The story of science is the story of the universe reading itself aloud through us. Think about that for a moment. Every measurement, every discovery, every bit of data is not just information, it's communication. The stars are speaking to us through light. We respond through thought. It's a conversation, ancient, endless, luminous. And if that's true, then imagination isn't a luxury, it's a responsibility. Because the universe can only dream through those who are willing to wonder. Perhaps that's why astronomy has always felt so profoundly human to me. It's not about escape, it's about belonging. When we gaze outward, we are not turning away from home, we are looking for home everywhere. Every planet we find, every spectrum we decode tells us that nature's creativity is vast, and that our existence is not an exception, but a continuation of that creativity. The diamond world, the world of fire and ice, the world that rains glass, these are not curiosities for a cosmic museum. They're reminders that the universe has never stopped experimenting. It never settled on one version of beauty. It tried them all. And so should we. We are in our own way artists, too, shaping ideas, building instruments, composing theories. We are reflections of the same imaginative force that paints galaxies. When we ask questions, when we explore, when we dare to wonder, we are acting out the universe's most ancient instinct to create. That's what makes this moment in history so extraordinary. For the first time, the universe has given rise to beings capable of understanding the scale of their own origins and of dreaming beyond them. For the first time, we can not only look up and see the stars, but look down and see ourselves as part of their pattern. And perhaps that's what the cosmic library really represents. Not a collection of objects, but a record of potential. A promise that reality will always be stranger, richer, and more beautiful than our imagination, and that imagination will always rise to meet it. We have only begun to read. There are entire wings of this library we haven't even glimpsed, planets still waiting for discovery, galaxies just forming universes perhaps beyond our own. Each one a page waiting for light to turn it. So the question isn't whether the story continues, it's whether we will. Because if we stop wondering, if we stop imagining, the library grows silent. But if we keep asking, if we keep building, exploring, learning, then the universe keeps writing. It's almost as though the act of curiosity itself sustains creation. When you step back from the shelves and look around, you realize that the library isn't somewhere out there. It's everywhere. It's in the air, in the soil, in the pulse of your blood. It's in every atom that remembers being a star. We carry it with us. We are made of it. And when we finally leave this room, this glowing chamber of thought and wonder, and walk once more under the open sky, the stars don't feel distant anymore. They feel intimate, familiar, like the pages of a book you've loved all your life whose ending you still haven't read. We don't yet know what the last chapter will be, but we do know this: the story's beautiful and it isn't finished. So tonight, when you look up, when you see those points of light that have traveled for ages just to reach your eyes, remember that you are part of their journey. You are reading the universe, and the universe is reading you. And somewhere out there in a galaxy you'll never see, another world is being born, a new story, a new idea, the next book on the shelf waiting for us to open it. It's beautiful, isn't it, that the universe never stops imagining, and neither should we.